Okay.
Okay, can we start now?
Okay. Hey guys, good evening. Welcome back to the .NET Developers Community Singapore. We are now doing live because the situation in Singapore is a little bit problem, but everything is okay. We probably next month we are going to do it in person again, so no need to worry. So I'm just going to do the opening first. Hey, as usual, don't forget to say try .NET. Even you are a .NET expert, try .NET. Say to everyone, try .NET. .NET Developers Community Singapore will help you. You just come to our meetup and you're gonna love it. And then as a developer, what we can do, Kaizen. We need to do the continuous improvement. What are we doing? Our code is not just simple C sharp code, but go all the way to the assembly if you like, if you want it, or if you need it. Increase the knowledge of the .NET and its related technology. For example, like now we're going to talk about this. Later, I'm going to introduce to you our speaker from US. Actually, 6 a.m. in the morning. I'm pretty sorry about that, but that's the timing. And then we have to always innovate and creating apps or enterprise apps. Follow or create your own best practice. Security wise, when developing web application, always optimize your .NET code. And key is NOS. Keep it simple. No, you are not stupid. I'm not stupid. And enjoy. Okay. So as a meetup, what can we do? Share knowledge of .NET. We do weekly meetup as usual every month, sometimes twice a month. Make a connection with other developers, spread the word, try.net to anyone, and then build the community bigger, better, and stronger. Okay, so guys, let's enjoy. I am going to share with you types of meetup: in person, hands-on, hackathon, and now we are doing the virtual online live. I am going to introduce to you uh, Shayne Boyer, if I'm not mistaken. That's how to pronounce your name. And I will give the floor to Shane to start the meetup. Go ahead, Shane, and introduce yourself.
Perfect. Thanks, Riza. I appreciate it. Yeah, as you mentioned that, unfortunately, we're not going to be in person this time. I wish I could be there in person. But I will put on my calendar that we'll make a visit out there at some point in the future, um, and do an in-person event, so we can meet the community that you've grown out there. I've been watching a couple of the events that you've recorded in the past, and certainly have grown a good community out there. So yeah, I want to talk to you all about building some microservices and using .NET Core to kind of scale and see what we can do with .NET Core when it comes to building microservices and Kubernetes, along with Visual Studio and some of the tools that the team has been working on in order to make that journey a little easier for you. So let's go ahead and kind of jump right into that. I'm going to go ahead and share my screen. All right, perfect. All right. So as we've known, we can use .NET Core to basically build anything right now. We have desktop applications, web apps, mobile, gaming, IoT, and obviously AI with ML.NET. But what I want to talk about today is building microservices and showing you how .NET can be used to build um, cloud development and microservices. So, uh, with the move to the cloud over the last few years, the industry has embraced this architectural pattern for building cloud scale and reliable services. Microservices are independent, they're immutable deployments with containers, and basically it's for improved scale and resource utilization per service. What this allows for is each of our teams to focus on basically what each one of these services does by itself, and only focus on that particular stack without affecting the other, and kind of use your own tools. So if you have um, one team who's operating on just a, I don't know, a customer service, and they want to basically deploy that without affecting the product service, that can be done and really not affect the deployment, version that independently, and scale it independently as well. And it allows for this higher velocity of deployments, and allow for basically smaller focused teams. So you don't have to have this super large team that has to worry about deploying these large monolithic, all-inclusive apps, and make it really difficult to deploy and manage these types of things. Um, and then deploying these and shipping these makes this operation a lot easier, and then scaling them with some confidence. Um, we have obviously on Azure now Kubernetes servers through AKS, which is completely managed, with a lot of ease and accelerated deployment through these containers. And it's really built on our enterprise grade secure foundation with Azure. And you can run anything anywhere, not only with .NET Core, but any of your languages. You have multiple languages on your stack with your application and your teams. We can manage all of this for you. There are a lot of other orchestrators right here, but basically we have standardized on Kubernetes as the industry has kind of moved that way, and it's one of the most popular ones. And with Azure, that service is completely managed. You don't need to worry about setting up or securing that communication between your services, and that's all automatically taken care of through AKS. Some of the other things that we've added recently in ASP.NET Core 3.0, and obviously made better with 3.1 recently, is some of these other microservice type technologies. First with gRPC, which is that high performant contract-based development with our RPC and .NET. It is a Google service, or developed at Google. We are working closely with them in open source to build in that support with ASP.NET Core. Obviously works across many languages, and we've built in that support with .NET Core to help you move that into your other applications. Secondly, we have a worker service now, which is basically giving you that ability to run those long-running services, but built on that foundation of what you're used to seeing in .NET Core applications. You probably have in your organization Windows services that are just sitting there and consuming messages from queues, doing some work, and running constantly. This new worker service allows you to give you that starting point for those services, like a background service. And now through a single line of code, you can actually use your ASP.NET Core, .NET Core-like foundations and set those up as a Windows service or a Linux daemon service as well. You can also put those worker services in containers and run them in something like Azure Container Instances and put them in the cloud as well, and have that all a part of your application stack. And then we continue to work with the stuff that we've put in place with Web API, give your Swagger, your client generation tooling all built in. And that's just some of the additional things that we've put in place with .NET Core as we move through 3.0 and 3.1, and looking towards the future with .NET 5, making all these things better in our tooling. So just real quick, we've got our downloads available for .NET Core 3.0 and Visual Studio. Check out the download links there. So what I want to do right now is actually jump into a demo and kind of walk through some of these toolings with with AKS and microservices, and just kind of walk through some real life capabilities through Visual Studio and some of these toolings to give you an idea of kind of what's available. Some of these things you may have seen, some maybe you have not, and give you a real in-depth look at kind of what's out there right now when it comes to building some of these services with these toolings that's there. So let me see, I'll hop out of this now and see if we can get some Visual Studio going. Again, I'm going to rely on my host here to hopefully show me that Visual Studio is going to work for us here. So let me see if I can push this aside. All right, so now we're in Visual Studio, and what we're going to do is we're going to run through just a couple of the features of kind of container development and Docker and Kubernetes development, and some of the features that we've got there. So I'm going to start off real quick with just an ASP.NET web application and run through some of the kind of container tooling that we have when it comes to Visual Studio and just some of the things that are there. So I'm going to start with a file new project and just fire up just an ASP.NET Core application. So I'll hit next and just call it. I'm going to actually start with 20 just to make sure that I don't have too many there. We'll hit create. And we'll just choose a web application, and I'm going to go ahead and create this enable Docker support here. And we'll just take off the HTTPS for now and create. All right. Perfect. And if we look at the solution, it doesn't look too much too different, other than it creates a brand new Docker file for us. And if we click on that, I don't know why my machine is being temperamental today. Visual Studio is being temperamental on me. There we go. There we go. All right. So basically, this is our Docker file here, and it's going to set up a couple of hosts here. It knows where to start from, so it's going to basically pull in our .NET Core ASP.NET 3.0 base image. Buster Slim is our base image. Yes, Docker is running. Thank you. Oh, you know what? It doesn't like the Docker was not running for us, so that's why. Okay, fine. And then Buster is a Debian-based image. It's a Linux-based image. So we're building on a Linux host for us. And then what it's going to do now is then set up a build layer for us, and it's going to copy in all of our images, all of our content from our project, and then build this on our Docker base images for us. So we have a Slim base, which basically just has the runtime. It doesn't have the SDK for us. And this is the output that we're eventually going to get to. So we're just waiting for Docker to start up. I bet that must have been what killed us here earlier, is that Docker for desktop decided to go to sleep. It's a little early for Docker apparently as well. So what it's going to do is it's going to start up Docker for us, and it's going to build our image. So we're just waiting for Docker desktop to start. Looks like that just about finished here, and build the image here. But if you look at the actual solution here, it's not any different. So we just go to startup. Looks like our standard web-based image, our web application startup. Nothing too fancy here. Still waiting for Docker to start here. Apologies for that. And then we have, again, all of our standard stuff that's going on here. Docker's still starting here. My goodness. Took me a long time for Docker to start here. We should be able to just fire this up as soon as it decides it wants to start. I'm just going to hit play and see if we can get this to build. There we go. Looks like Docker started finally. All right, and now we should be able to see our output here. Come on, Docker. It looks like our host, um, our streaming host is really really churning here. Let's do this. See if we can get our container tools to tell us. Okay, looks like that's working fine. Let's see if we can do. There we go. Sorry about that. So it's going to actually start up our container. Now it's actually building our containers. If I can pull this up here. It's actually building the image for us. You'll see that it's actually building, these are actually the build commands here. It says you're building the Docker image from the Windows host against a Linux. So it just kind of gives us a warning saying, hey, listen, we realize that you're on a Windows machine, but you're building for a Linux image. And now it's been finished. So now that once we finish building that image, we should see the debugger actually start now, and I'll actually run the application. We're really using all the bits here. Perfect. Now we're starting up here. One of the things that I wanted to point out is once we start an application that's running inside a container, we actually have a new tool set that's inside of the Docker container tools for Visual Studio. And this is the new containers pane that's here that I'm highlighting. And once we start, once the application starts up here, we'll be able to see all of the information that's running inside, all the information about the container that's running. And here we go. You'll see that this is web application 20, as I named it when we started. We see the output over here on the right of all of basically the logs building. And it looks like I started over here on the other side. Let me pull this window. I'll minimize it here. This is the actual web application 20 running. It's running inside of the container. And as I hit refresh, you'll see that the logs over here are running, which is perfect. If I go back to Visual Studio, here's all of our environment variables that are running inside of the container. We can look at the ports. Here's our port 32768, which maps directly to our host that's there, which is great. We can look at the logs that are inside of the container. So these are the same logs that you'll see on the right-hand side here in the output that are coming. These are coming right from the container. And the other wonderful thing too is we can actually browse the file directory inside of the actual container. So this gives us the ability to look at the files you see in app. If I go back and I look at my Docker file here, here's the working directory of /app. Here down in the bottom here, you see app, which is the folder inside of the container. And there's my actual files that got copied over. And I think that's pretty awesome that I can see my actual files that I can move into the container. Now I can browse them and see that they're being copied over. Really good way to debug. If something goes wrong, I can actually look inside the container and see what's going on in there. Another great thing too is we have debugging. It's been there for a while, but it's always good to see that. If I actually go into my file directories here and I look at index CS, actually let's look at one that's even here. If I hit a debug point on this onget, go back to our browser, we hit refresh, we should be able to get our debug, and great. I'm actually able to hit my breakpoints while running inside the container and have that real nice development inner loop that I'm used to hitting when I'm developing things as if I'm not in a container as well. This gives me this nice, warm and fuzzy feeling. And then I'm working just as if I was working in the local host. And I know that when I'm developing inside the container, that's going to run the same place everywhere. And that's really great. All right. If you have any questions, please put those in the chat, in the YouTube chat, and we can address those later on. If you have any questions about running inside the containers and also inside of the Docker tools, if you have any questions about that, please feel free to ask about that. So that's all well and fine that we have all of that capabilities, but what if we wanted to develop microservices? This is a microservice, obviously, because it's a single responsibility. It's running inside of a container, and that's kind of the core definition of what a microservice would be, is single responsibility. Now, this is a web application. It could be a web API. It could be hitting a database. It could be doing a single service type of thing, and we could deploy it. The biggest challenge is when we're developing these services and we want to run them on Kubernetes. Now, I could set up Kubernetes on my machine, a Kubernetes cluster on my machine, and I can enable that inside of my Docker desktop and run that locally. I might not have that capability. I might not want to do that, right? But maybe I want to. I need to set up that. Maybe I have a project I'm working on. Maybe I've got a cluster somewhere in Azure that I need to run that on. How do I deploy and run and debug and have all these capabilities as a developer using Visual Studio? So one of the things that I can do in Visual Studio is I can connect to my cluster with Azure Dev Spaces. And if I decide now, instead of running in Docker with my debug menu, you'll see that now I have Docker enabled because in my application, it saw that I had a Docker container. I can run it in Docker and do the things that we just did. I can also run it in IIS Express on my machine. If I chose Web Application 20, it means I'm running it in Kestrel. But I can choose Azure Dev Spaces now. When I choose Azure Dev Spaces, I get a prompt now that says, select the subscription, select your Azure Kubernetes cluster that you want to develop against. Now, I've already set up a Kubernetes cluster in Azure. You may have had somebody in your operation set it up for you. And I'm going to select mine. Hopefully I select the right one. We might have to run through this again. And we'll see. And it's going to ask for a space. And a space is just the location that you are going to operate in. I can create a new space. And I'll set up a new one called Meetup. I'm going to choose publicly accessible, and what that means is it's going to allocate a public IP for me to hit it outside of the actual Kubernetes cluster publicly. So if I had maybe a gRPC service or a web API that I only want to be available within my actual application, inside the application, I might not want to have that. Or maybe it's just a worker service. I might not want to have that publicly accessible. But since this is a web application, I want to make sure that I can hit that externally from a public IP. So I hit OK. And if I look at my container tools, maybe it's my output, my debug. It'll be setting up those things for us. Here we go, Azure Dev Spaces. It's going to start up the warm up for us and start to prepare that dev space for us for our actual Web Application 20. You'll see that it's creating that meetup space for us. It realizes that our Web Application 20 doesn't exist, that we have not published it to that space before. And now it's going to start creating that space for us. You'll see that it's already created our URL in that cluster for us. And it says it's building the container image. Now you remember when we first started in Visual Studio, it had to start up Docker desktop on my machine. Again, I apologize, it took some time for that. You actually don't have to have Docker desktop running on your machine at all. All of this build of the container and processing of that does not happen on your machine. It actually happens within the cluster. And what's happening here is Visual Studio is pushing your code up to your AKS cluster, and all of this build is happening actually within the cluster itself, which is really great because now I don't have to have. You'll see in my this processing, this networking here, all of that 85%. That's actually just me hosting the stream of talking with you. It's not actually doing any of the Docker stuff. I can actually shut down Docker, and all of this work is actually happening inside a cluster. So all of this processing and building of my container is actually happening out there. So now when I hit my debug, I'm actually going to be running in the cluster in AKS. And I can have multiple services. Here I just have one web application, but I could in fact have multiple applications. I could have a web API, multiple gRPC services. I could have multiple web APIs all talking with each other. And I would have to move my browser over here. You'll notice that the URL that we're hitting is not that local host URL. It's actually hitting the Meetup URL. I'm just waiting for this thing to load. And we should, in fact, see the same application come up. Says it's loading. Oops. Clicked away here. And what happens is it's actually created a route that goes between a local host and my machine. Sorry, my machine and the cluster. So if I look at my logs, I might have to start this again. Sometimes they're routing. It's a little finicky. Let me stop this. Oh, my fault. That's my mistake. Oh, that was my mistake because I had a breakpoint in here. Look at that. I hit the breakpoint already. Let me hit stop.
No wonder. I was thinking it's pretty long today.
Yep. It worked too good. I actually had a breakpoint in there. There we go. So, yep.
Awesome.
Meetup. That's pretty good, huh? So, yeah, if I hit that breakpoint in there, I was wondering, why is it spinning so much? It's a common developer mistake. Like, why is my app not working? It's because you have a breakpoint in there. What was one of your bullet points? What was one of your bullet points, Riza? You're not that stupid. So let me go back to the app here. Yeah, if we hit refresh, we're hitting our breakpoint here, which is really great. So I'm actually hitting a breakpoint. If you can just think for a moment, I've got my application. It's running in Azure in a Kubernetes cluster, and I'm hitting a breakpoint on my machine. And that's pretty fantastic that I'm able to do that. Now, I could have another application. I could have, like I said, multiple applications where I've got web API, gRPC, a number of things, an entire stack, all running in Kubernetes, and then able to step through this and debug my application as if it's running in production. So if I had an AKS cluster set up as a development environment or as a QA environment, and being able to connect to that environment in my development tools and run through those and debug them is pretty great, right? I think that's pretty awesome. And I still get those same, if I refresh this, we should be able to see those same type of tools that are available to us in the containers because we're running the same exact container. in there. It still builds that tool, so we're able to see that those tools in there. So I run in the container, I build it, I'm able to see those types of things, and these tools will start to get better over time and be able to see what's available from us also in Kubernetes, right? So I think that's pretty compelling tooling when it comes to running those services in Kubernetes and be able to um, debug those items while running in a cluster in the cloud. Something that wasn't available to us even a couple of years ago. Um, this was the hardest part about running and developing tools and microservices when it comes to.
Hold on, let me check chat. Hold on.
It's quiet.
It's quiet. I was asking if we had any questions. No.
I guess no.
No. Okay. All right. So let me do this. Let me get back to the presentation here, and hit the right button. All right. So we have our downloads. A couple of the resources here that I just wanted to point out was we had a keynote. This is a bit of an older link, but it really runs through a number of things there. We had a keynote from .NET Conf. It was from September of last year, but we made the code available. It runs through a lot of the microservices, and it's a really good demo app. It's available on that first AKS keynote weather app. Some of the other great tools just for debugging when it comes to building APIs is the .NET Core HTTP REPL, which is that just ability to debug your web APIs on a command line, and that's available there at that .NET Core / HTTP REPL. One of the other pieces of the demo that I just showed briefly, it was just actually in the code, was one of the features that came out recently was endpoint routing. Good resource there, just AKS/endpoint routing, and also health checks is also available. One of the other things that I'm a host of is the Cloud Native Show. It's a show that comes out. We have episodes every couple of weeks. If you just go to aka.ms/Cloud Native Show, it's a really good show. I get a chance to talk with a lot of the engineers who build some of the tools and technology that we walk through today. Some of the Docker tooling, some of the Kubernetes things, and I get the chance to really just chat with them about some of the just really great stuff that we're building and kind of show off some of the campus and things there too. So have a look at that. And if you have any questions in the meantime, please feel free to reach out to me on Twitter. I'm available all the time there. And it was good chatting with you guys. Again, I hope to make my way down to the meetup in person and spend some time with you and chat with everybody that's there. So I appreciate you having me on, and looking forward to hearing more about what you're doing there.
Okay, Shayne, I have a question for you.
Yeah.
Okay, so regarding this cloud native architecture, so what is the best architecture that we use? Supposed to be, for example, we use CRUD, CRUD for our web API, for example. Which one is better? Should we use a CQRS, or it's kind of like event sourcing kind of thing, or CRUD? Because there's a lot of enterprise using CQRS in terms of the required for the separation between the command and the queries, for example.
Yeah. Yeah. There's a lot of I think there's a lot of folks out there that like CQRS and event sourcing. I think that I'm not a CQRS expert. I'm not. I haven't used it since probably it very first came out. I would say that my advice when it comes to those different types of patterns is try them all out. a little bit, like I say, would experiment with them each individually to some degree and kind of see what feels right when it comes to number one, your team, and see what makes the most sense. I find that it kind of, I would say the most recently, some of the patterns that we're seeing is really using it. Event hubs has been a pattern that some of the customers and that I've spoken to recently just uh, seem to like. Just really, it's event messaging, um, and dealing with it from kind of that pattern a little bit. Not to say that that's the right one versus the next. I think everybody kind of um, works with different architectural patterns and sees, you know, um, what fits their kind of organization the best. CQRS obviously is very popular. Um, I'm of an opinion where simple is better, but it really depends on kind of what feels right for your org, and really who was the architect at the time. You'll see a lot of that happen, like, hey, this is the way we've always done it. Um, so I would say that I don't think there's one that's better than the other, quite honestly. Obviously, security is top of mind for a lot of companies right now. So what is the most secure way to put your architecture in place? So I don't know if that's a good answer or a bad answer, but I would say that experiment with each one of them individually and see which one makes the most sense to you as a company and your team. You don't want to implement an architectural pattern that is just very obtuse, and you spend more time trying to understand the pattern than you are actually writing code, if that makes sense.
Yeah, fair enough. The other thing that a lot of community members asking me is, if we're using this kind of like Kubernetes, how do we store the database? Because sometimes the service, if you look at the example that Microsoft gave in the GitHub, it seems like each of the service has its own database. And if we want to have a collection of the main database, do we have to create another image, Docker image, and put in Kubernetes to run the SQL Server, and then point to the storage outside of that Kubernetes? This kind of thing. There's a lot of question from the community members actually. Maybe you can make it simple for that one.
Yeah, that's a very common question that comes up. When you start talking about data and Kubernetes, or data and just containers in general, but it's like, what do I do with my database service? Um, I'll say that the pattern that you'll see when it comes to dealing with microservices is, yes, most microservices will have their own database. Now, what does that mean? It means that they have their own either subsection of the database. So you could have a very large, and I'll use SQL Server as an example. I could have a SQL Server as a service. So let's say it's Azure, it's SQL Server on Azure. Okay. And that SQL Server could have multiple databases. It could have one huge database with multiple schemas. Um, it could have, it could be broken up into many ways. And a service, a microservice that does a single thing, can only touch maybe a subset of that data, if that makes sense. Um, to start trying to put um, the actual database service inside of a container, and then binding to data that's on storage, and trying to manage all of that, that is a lot of work, because then you're starting to try and deal with the sovereignty of the data, and trying to manage the reliability of the data and backing up all of that data. There's just a lot of things that can go wrong. So my recommendation is use a database as a service. Don't try and put that database into a container, because if it's Azure or if it's some other cloud provider that has a very reliable database as a service, they can do that job a lot better than anybody trying to manage it all inside of containers, if that makes sense. Um, so use that database as a service to your advantage. Use the way that they can, break it up into schemas and break it up into manageable parts. Um, use that database as a service to your advantage. Don't try and put it all in containers. It just doesn't make sense. Um, Now, if you want to use something like Redis or something like that for temporary caching or temporary data stores, fine, you can do that in containers. But don't try and put your major data stores into containers and then bind that to volumes. Um, that doesn't seem to have a long-term reliability story.
Okay, so here's my last question, probably from me. The other thing is that what is the best communication within inside the Kubernetes? For example, between microservice they want to talk. I usually use like N service bus or RabbitMQ, but some of them using Kafka, for example, just to communicate within the service. Any particular service, any particular messaging service that you think is the better way? Because obviously we cannot use dependency injection inside
Yeah,
because it's a separated service. Which one is kind of like not a choice but an option? What
yeah,
is the best option that is good for enterprise, for high scalability, performance, etc.?
yeah. So that's a good question too. In-service bus has been around a long time. Um, and I think that if you're talking about service to service communication, is that what you're asking?
Yes, correct. Between two services inside the inside the Kubernetes, we there were one of them is, for example, like ordering engine. The other one is notification engine. They want to speak to each other to send a message,
Yeah,
that kind of thing.
yeah. I mean, Kafka is actually everything you mentioned is all good choices. Um, I think that um, like I said, in-service bus has been around a long time. Kafka is very scalable. Um, if you're just talking about just messaging between the two, just direct communication, gRPC is obviously very popular now. In fact, just the core pieces of Kubernetes, a lot of it works on gRPC. Um, so that's just straight communication, like API to API. It's binary, it works very fast. But as far as passing messages around, kind of queue-based messaging, there are a lot of options out there, and I think I would go back to what I said before about when about your CRQS, your CQRS question. Again, it's going to be kind of what your application is asking for, and how that architecture is set up. Kafka might be just too much for you. It might just be kind of over the top. RabbitMQ is very popular, very fast, reliable. I like Rabbit. I've used it quite a bit. I think that for me personally, it's the one I feel most comfortable with. I think it's super easy to learn and scalable, but it might not be for your particular team. Um, but there's also, like, within Azure, um, within a lot of the cloud providers, they might have a particular um, product choice that works great. We have event hubs. Event hubs is perfect for us, and that's a service that I don't have to manage. Um, so I like to use services that I don't have to worry about managing all the infrastructure on. I can just use that particular service. So sometimes there's offerings there that are great too. I try not to manage every single piece of my architecture if I don't have to. Kind of back to that database story. If I don't have to manage everything, and I can rely on somebody else to kind of do the homework for me, I think that's also a good choice too.
Okay, okay. This one is personal for me because I've been playing around with this Kubernetes, but somehow I'm thinking like, do every service inside the Kubernetes require reverse proxy, or we can just use Castrol to beam the message, the service out, or do we need some kind of like a engine X or whatever IIS if exists in Kubernetes image? I mean, Docker image.
Yeah, that's a good question too. I mean, Kestrel, I think our recommendation is still to use a reverse proxy if you're going to expose that externally. Um, I mean, Kestrel is still a very capable, web server to do the work, and it's still getting better over time. But I think that still using a reverse proxy um, is recommended for us to do it. And I think that we are obviously looking for to ways to improve either Kestrel or maybe our own solutions moving forward. Um, but right now, I think Nginx is very reliable and it's been around a long time. I think that's still in our docs as the way to do it. To put that out there.
Okay, no more question for me, Chunlin.
Okay, Julian, you got any questions?
No, not really. I'm still a beginner in Kubernetes.
Okay. Well, I appreciate you guys taking the time and having me host. It's been a good time. I enjoy the topic. Again, like I said, I'll be sure to put Singapore has still been on my list a long time to get out there, and extenuating circumstances has kept us from meeting in person. So I look forward to our future dates.
Yeah, for me, thank you very much, Shayne. We love having you here speaking to our community. The members will be very happy, and definitely we are hoping that you can come down to Singapore and